This lesson is on FNN, which stands for Formulas and Nomenclature for Binary Covalent Compounds. All right, so we are looking at binary compounds whose first element is to the right of the staircase. For today, the only thing that you'll need is a periodic table. So we have our staircase on the periodic table. So now this is when the first element is to the right of that staircase. Okay, so these compounds who fall into that category are covalent. The bonding is from sharing of electrons. Right, what do we mean by the term binary? Binary means that there are two different elements in the compound. So this means two different elements. And this is not diatomic. Diatomic means two atoms. Binary means two elements. So for example, CO, one carbon atom, one oxygen atom. Another example is N2O4. Two nitrogen atoms, four oxygen atoms in one molecule of N2O4. So we have two different elements, but we can have any number of atoms of each of the elements. Okay, so for formulas and nomenclature, we are going to use a different system than we did for our ionic compounds. We are going to use the prefix system. And the reason we're using the prefix system is that this is the most common system. When you see the names of some of these molecules, you're going to be like, yeah, I know what that is. I've heard that. So there is a stock system for these compounds, but it's really not used at all. The prefix system is by far the more popular system for these types of compounds. Okay, so how does the prefix system work? We are going to use a prefix before the element to denote the number of atoms of that element. The first element gets its full name. And the second element ends in IDE. Okay, now with our prefix system, guess what? No charges to worry about. No crossing, like we did for ionic compounds. No Roman numerals. How about that? And no reducing to lowest whole number ratio. So all of these things that we had to do for the stock system, we do not do for the prefix system. So it is actually a much easier system to learn. Okay, so let's go over the prefixes. So we're going to look at the number of atoms and then the prefix for that number of atoms and the prefix. So if we only have one atom of the element, our prefix is mono. like monochrome means all one color. All right, now there is a little exception to this. We only use the prefix mono if the second element has one atom. So this is only if the second element has one atom. If the first has one atom, we don't need to put anything. It's understood. And we'll see examples of that, and it's going to sound correct. All right, so if we have two atoms of our element, our prefix is di, like diatomic, meaning two atoms. If we have three atoms, our prefix is tri, like a tricycle has three wheels, or a triangle has three sides. Four, now four, if we go to when we did geometry and we had 4 electron sets, we said it was tetrahedral. The prefix of 4 is tetra. Tetra. And then 5. Now we're going to go back to our geometry shapes. If we have a 5-sided figure that is a pentagon, the prefix of 5 is penta. If we have a 6-sided figure, it's a hexagon. The prefix for 6 is hexa. If we have a 7-sided figure, now you might have heard of septa, but in chemistry we use hepta, H-E-P-T-A for 7. 8 is octa, like an octagon. 9 is nana. Well, you can have a nonagon. And 10 is deca. 10-sided figure would be a decagon. Okay, so let's do some examples and put this into practice. So example, and I think you'll probably recognize this one. If we have the formula CO, now we want to name it. So our first element, carbon, has one atom, so we don't need the mono for that. So we just write carbon. Our second element does have one atom, so we do need the mono. It has to end in IDE, so it will be monoxide, but we're just going to kind of put that together into monoxide, carbon monoxide. So you probably know that that's carbon monoxide, right? Very dangerous chemical compound there. All right, if we have CO2, and you probably know what this is without using the system, because we've been using the prefix system. So one carbon is just carbon. Now we have 2 oxygens, our prefix goes in front. 2 is di, so this is dioxide. Carbon dioxide, you probably already knew that. Let's look at one I gave you previously, N2O4. Now here, the 2 is on the first element, so we have to have a prefix for that. 2 is di, so this is di. The first element gets its full name, so this is dinitrogen. 4 is tetra, so this is tetraoxide. Or we can kind of mush that together and say tetroxide. Now, if you put tetraoxide, I'd be okay with that. I'm not going to be real picky about that. Another example is SF6. This is a very dense gas. And so we have 1 sulfur, so just sulfur. We get the full name for sulfur, our first element. 6, our prefix of 6 is hexa. So this is hexa fluoride. It is that easy. No charges, no crossing, no Roman numerals, none of that stuff. All right, let's go the other way. Let's write a name and come up with a formula. So we might have a compound arsenic, penta, chloride. All right, so we need to remember our element symbols. Remember, arsenic is AS. AR is argon. A lot of people make mistakes with arsenic, AS. And there's one of them, because there's no mono, we don't need the mono. If there's no other prefix, it means we have one. So AS. Pentachloride, so chloride comes from chlorine, Cl. Penta is 5, so our formula is AsCl5. That's it. It's that easy. Let's do another one. Diphos for us decoxide, or decoxide, or decaoxide. Okay, so di in front, di is 2, so this is P2. Oxide is oxygen. How many oxygen? Deca is 10. Okay, and we do not reduce to lowest whole number ratio. We keep it just like the name tells us to. So that's it. That is how you do that. Okay, but I am going to talk about some more compounds. Okay, CH4. If we were to do that with the system that we just learned, this would be carbon, 4 tetrahydride, tetrahydride. That would be the way to do it with the prefix system. However, this is our Bunsen burner gas. And I've mentioned our Bunsen burner gas a lot. We've done chemical equations with our Bunsen burner gas, and I've never said carbon tetrahydride. When I talk about our Bunsen burner gas, I always refer to it as methane. Methane gas is our Bunsen burner gas. So we have special names for hydrocarbons, and we're going to talk about them now. Okay, so what is a hydrocarbon? So a hydrocarbon, the name pretty much tells us. So these are binary, 2 elements, compounds, containing, no surprise, hydrogen, and carbon. When we do the formula of a hydrocarbon, even though the name is hydrocarbon, we always put the carbon first. So our formula would be CX, some number of carbon atoms, and HY, meaning some number of hydrogen atoms. So X would be 1, Y would be 4 for methane. All of our hydrocarbons are fuels. They undergo combustion reactions. So you burn your fuels, and if we get complete combustion, we get carbon dioxide and water vapor and energy from that reaction. So hydrocarbons produce energy when they are burned. We get heat and light. So they're a very important class of compounds. Now, there's thousands of hydrocarbons, but we're going to concentrate on a small subset of hydrocarbons. We're going to do the F and N, the formulas in nomenclature, the formulas in the names for hydrocarbons. With all single bonds. So all the bonds, well, hydrogen's only going to make single bonds, but carbon can make single, double, or triple, but here we're limiting ourselves to when the carbon-carbon bond is always single. Okay, so for this F and N, we're going to use a prefix for the number of carbons. And some of these prefixes are a little different than we just learned for the regular binary covalent compounds. And the name ends in ANE. Name ends in ANE. Okay. So let's take a look at these. All right, so we're going to look at the number of carbons. And we'll look at the prefix for that number of carbons. We'll do the name for the compound. We'll look at the structural formula. And our chemical formula. All right, so if we have one carbon, our prefix is meth. The name of the compound is methane. The structural formula, so this we're not going to show the 3D structure, we're just going to do everything flat. So we have a carbon with 4 hydrogens. And our formula is CH4. Because when carbon makes single bonds, it always makes 4 bonds around it. And we know that this would be tetrahedral, one hydrogen up, one hydrogen off to the side, one hydrogen sticking out in front, and one hydrogen going to the back. All right, if we have 2 carbons, our prefix is eth. So our compound name would be ethane. So we have 2 carbons, single bonds only. And now we have to fill in the rest of the bonds with hydrogen. Again, carbon's going to make 4 bonds. So we have an H, an H, 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 H. So our formula is C2, H, 1, 2, 3, 4, 5, 6, H6, ethane. All right, if we have 3 carbons, our prefix is prop. So our compound name is propane. And we would have carbon bonded to carbon, all single bonds. Fill in with hydrogen so that each carbon has 4 bonds around it. And so our formula is C3H, 1, 2, 3, 4, 5, 6, 7, 8. 8. So propane, if you have a gas grill and you have a tank with that grill, this is what's in that tank. It's a propane tank for propane gas that has this hydrocarbon that you use to light the fire and cook your food. All right, if we have 4 carbons, it's not tetra, it's bute. So our name is butane. And I'm not going to go ahead. You could do that if you want and make 4 carbons and fill in the hydrogens. Our formula is C4H. You'll find you have 10. 5. Now we're back to the same prefixes that we have, but we kind of take off the A. So this is pent, pentane, C5H12 for 6. Hex, hexane. So I guess it's buta, pentahexa. I guess that's true. And then we just take that A off for A and E. Hexa. We don't say hexahexane, we say hexane. All right, and then 7, hepta. So this is heptane. C6, H. 14. 8 is octa, so octane. C8, H18. And if you hear about the octane rating in gasoline, that's what they're talking about. Octane has the formula C8H18. All right, and then 9, nana, nonane. So that's C9, H20, and then we have 10, so deca, this is decane, which is C10, H22. So there is a pattern here with the formula for the number of carbons and the number of hydrogens. So that formula is C, we can say X, H, 2X plus 2. So if we have one carbon, 2 times 1 is 2, plus 2 is 4, we get CH4. If we have 2 carbons, then hydrogen is 2 times 2 plus 2, which is 6. So we have C2H6. If we have 10 carbons, 10, 2 times 10 is 20, plus 2 is 22, C10H22. So just knowing the number of carbons, we can figure out the formula of our hydrocarbon. Okay, so if you have the first element to the right of the staircase, if it's a hydrocarbon, we're going to use this. And then if it is not a hydrocarbon, then we're going to use these prefixes and do it according to the examples that we already did today.